Hey everyone, hope you're doing well. Today we're going to be talking about graphing vertex form, and I'm actually going to show you guys something today that I've kind of wanted to show you the whole time, but I've held off on. But I think this makes it easiest to graph quadratics, okay? And that involves knowing the 5 points of the parent function. All right, so if we look at the parent function y equals x squared, okay, if we square each of these numbers, all right, 0 squared is 0, all right, so that's your vertex right there in the middle at 0, 0. The next 2 points on either side, 1 and -1, both of those two numbers squared equals 1, right? So the first jump that you make is an increase in 1. Right? So we're going up 1, up 1. Come on. The next number squared, 2, all right, 2 squared is 4, -2 squared is also 4. So the second jump from the vertex that you make is up 4 because that's the next perfect square. All right, and it keeps going, right? The next jump would be 9, 3 squared is 9, then 16. So if you know what the perfect squares are, you can get your points pretty easily, right? Once you have the vertex. So this is the parent function for the quadratic, right? Those are the main 5 points. We've always been talking about needing 5 points, right? So if you know the vertex and you know that it increases by 1 the first point over and it increases by 4 the second point over, you can get your other 5 points pretty easily, okay? And the way to get the vertex, and the kind of way to understand this is built, is with vertex form is by looking at all the transformations. So we've talked about transformations before, but we'll go over these real quick, right? The big one is A. A does a lot, and A can really change the graph. If A is greater than 1, that's a stretch, all right? If A is between 0 and 1, that's a compression. It gets fatter, it gets wider. It opens up if A is positive, and it opens down if A is negative. We've talked about this plenty of times, and this happens with literally every function we'll look at all year. It gets flipped if A is negative. Then we have our 2 shifts, right? H, that's our horizontal shift. Remember, these are the numbers controlling the vertex because it's moving it around. H is moving it left or right. K is the vertical shift. It's moving it up or down. And if you know these transformations and you know the parent function points, then you can get your new points pretty easily, okay? So we're going to look at this graph. We're going to list the transformations here. The first transformation that we have is H. That's kind of the first thing that happens to it. So +5, remember, it's the opposite with H. So that means H is -5, which means it's going left 5. And then we also have that -A value out in front, which means it's being reflected. It's being flipped upside down. Okay? And if we know these original 5 points, right, we can just transform those 5 points, okay? So these 5 points are going to be flipped upside down and moved to the left by 5. So we're going to go over to the left by 5 there. We're going to take these other 2 points. So if I'm looking at this point right here, right, I'm going to go 1, 2, 3, 4, 5, but then it needs to go down 1 instead of up 1. The other point right here, we're going to be going over 1, 2, 3, 4, 5, and then down 1. These 2 points up here, all right, we're going to do the same thing. 1, 2, 3, 4, 5, except now I'm up 4, so I need to go reflect to being down 4. And then same for this other point, right? We know it's going to be right here because it's the next one over, and we know it's got to be down 4. Okay, so these are the 5 points, and then we can connect them, we can make our graph, and we can call it a day. So what I was talking about before, the jumps, right, they're still here. Okay, the first point over from the vertex, we're going down by 1. Then the second point over from the vertex, we're going down by 4, right? And that happens on both sides. So if you know these parent functions and you just move them around, you can make the graph pretty easily, right? Let's look at our new points. We've got -5, 0. Oh, that should be in the middle though, because that's the vertex. On either side, we've got -4 and -6. Those are going down by 1. On either side of that, we've got -3 and -7. Those are going down by 4. So all the parent function points have been flipped upside down. So we're going to look at a couple more here, okay? Next example, all right, what's happening here? So here we've got a -4, so that if we're looking at the vertex, that means the vertex is at 4, -4. The axis of symmetry is at x equals 4, right? So let's put that point in the middle, right? 4, -4. We know on either side that we're going up by 1, right? So what's up by 1 from -4? That's -3. We know at 2 and 6, the next point's over, that we're going up by 4, right? What's -4 plus 4? It's 0 and 0. Look, all of a sudden you've got all 5 points. We got 4, -4. We know the next points over are going up by 1. So there's our 3, -3, and 5, -3. And then we know the next point over, we're going up by 4. 1, 2, 3, 4. And 1, 2, 3, 4. And so, just like I said, we're right there on the x-axis. We get our 5 points and we're done. So you guys can use Desmos. All right, I've shown you Desmos so many times. If you don't know Desmos at this point, then that's on you to get the points. But I'm just saying, at a certain point, you don't really need Desmos. This is how I graph. All right, just letting you know. So we look again, all right, where's our vertex at here? So we take the opposite of this number, that's 3. We take this number, that's 2. So our vertex, that's going to be at 3, 2. So let's plot our vertex. And then before we start adding our points, let's look at our a value. Hey, shh, stop. We got an a value of -1, okay? So what we're going to do, we're going down, right? So we look at our vertex. We know the first points over from our vertex is going down by 1. So where are these other 2 points? Well, they're at 2, 1, and they're at 4, 1. Where's our next points over? Well, we know they're going to be at 1 and 5, right? But we're going to be going down by 4. So 1, 2, 3, 4, right? 1, 2, 3, 4. And there's our next 2 points, all right? And there we go. Where are they at? They're at 2 minus 4, which is -2. So you can do the points first, you can do the table first. It doesn't matter, all right? You should be getting the same thing regardless. Okay. Now, what do we do if there's an a value that's being stretched or compressed? Okay, well, that doesn't affect us that much, all right? So we look here, we've got our vertex is going to be at 1, -3. We take the opposite of the h value, and then we take the k value. So let's put our vertex here at 1, -3, okay? Now, what happens with the stretch, right? Because we know it's being stretched. Well, because it's being stretched, all right, all of our jumps are being multiplied by this, okay? So if we know the normal points, right, the normal first points over are 1 and 1, okay? But what's happening here is that it's being stretched by 3. It's getting skinnier. So all these points are going up by a factor of 3. So we have to, instead of going up by 1, we're going up by 3. 2, 3. And so there's our new next point. So they went up by 3, right? So we've got a 2, 0, and we've got 0, 0. Now what's our next jump, right? Well, normally our next jump, they're up by 4. So they'd be right here. Right? Except now it's being stretched, right? So instead of the points being up by a factor of 4, Now, or sorry, instead of being up by 4, now we have to stretch them by a factor of 3. So 4 times 3 is 12. So these points actually need to be up 12 from the vertex. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, it goes off the graph. 12. And the other point will be on this line directly across, because up 12 will be on the same place. So look how much this stretched, right? Holy moly, it's up there at 3, 9 and negative 1, 9. So again, you can see the power of that A value, how fast the graphs can move up with a higher A value. So this would be one with a stretch. So all you have to do is, instead of the jumps of 1 and 4, you just multiply them by whatever your A value is. If it's a half, you go up by a half, and then you go up by 2, right? And so that that makes it shorter, makes it fatter, wider. So this is how you do this. Like I said, you can use Desmos, all right? I'm not gonna say you can't. If you want to put these in Desmos, make a table, get your points, go ahead. But if you think you are starting to understand what you're doing, you can do this a little bit faster, right? So here are 4 questions that I want you guys to do. I want you to give them a shot. All right, if you have any questions, let me know, and have a great day.